Hello, Accelerated Math 6-7 students. We are working in Module 4, and today we will be focusing on Lesson 7, and it is called Factoring Expressions, and it can be found on page 72 of my book. So I'm going to turn there now. 72. Okay. Factoring Expressions is what this one is called. Okay. So factoring expressions, the goal. Today we will learn how to write and model expressions using the distributive property. Okay. Question, how do you use the greatest common factor and distributive property to write equivalent expressions? Today we will learn how to write and model expressions using the distributive property. The question, how do you use the GCF or greatest common factor and the distributive property to write equivalent expressions? That's what our focus is. Okay, things you need to know. GCF stands for greatest common factor. Okay, the largest number that two numbers have in common. Okay, so if we take, this is not a negative, this is just a list mark. So if we take 12 and 18, those are the two factors that we are given. We're trying to find the greatest common factor. So that means the factors of these two numbers right here that they have in common. So the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Because 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. 18 is 1 and 18, 2 and 9, and 3 and 6. Okay? So your first job when you're trying to figure out your greatest common factor is to list out all of the factors. So that's what I did right there. Then the second part of your job is to go back and circle all of them that they have in common. So I used a different color. So they have 1 in common, they have 2 in common, they have 3 in common, 4, no, 6, yes, 12, no, 9, no, 18, no. So I've circled all of them that they have in common. The last job is to go back and pick the one that is the greatest. So looking at all 4 of these options, 6 is the greatest. So our GCF between 12 and 18 is 6. Okay? So that's how you find the greatest common factor. Next thing that you need to know, factored form. Factored form means that you find the GCF and you factor it out. Factor means to divide out of the whole and figure out what the answer would be. So if we have 20x plus 5, the two numbers that we are comparing, just like 12 and 18, the two numbers that we're comparing in this one are 20 and 5. So I list 20 and I list 5, and then I find their factors. Okay, so if I'm doing that, then I have right here 20, 1 times 20, 2 times 10, 4 times 5. Those are the factors of 20. The factors of 5 are 1 times 5. Then I circle the ones they have in common. So they have 1 in common, they have 5 in common, and then I decide which one is the greatest. The greatest common factor is 5. So now it says up here, factored form means that you find the GCF, which we did, and factor it out. So when you're factoring it out, you're saying to yourself, how many times does 5 go into 20? The answer is 4. How many times does 5 go into 5? The answer is 1. So when you factor it out, you pull it out. And so the 5 is now sitting on the outside because we pulled it out or we divided it off. Okay? So the opposite of dividing is multiplying. So watch what happens. If you take 5 times 4, what do you get? 20. Good. If you take 5 times 1, what do you get? 5. So do you see how we factored it out? We divided it off and pulled it out. So when we divide the 5 out, it sits outside. Then you do your parentheses, which create the quantity, and you write what's left inside. So 20x divided by 5 gives me 4x. 5 divided by 5 gives me 1, and I'm adding them together, so that's where I put the plus. So 5 times the quantity 4x plus 1 is equivalent to 20x plus 5. And if you go back up here to our goal, it says, today we will learn how to write and model expressions using the distributive property. Did we just do that right here? The answer is yes, we totally did. Okay, next part that you need to know, expanded form Expanded form means separate each part of the expression. So again, we're using 20x plus 5, and so we're separating them so that we can see what is there. So we know that 20x plus 5 really looks like in expanded form 20 times x plus 5. Another way to write it in expanded form maybe could be 4 times 5 times x plus 5. So expanding it out, breaking it apart. Okay? Here's another example of expanded form. If your standard form was 7g plus 9h, expanded form would be 7 times g plus 9 times h. So do you see how we're breaking everything apart and writing them separately? So that's expanded form. Okay? And that's all that we have as far as things to know. So what you're going to have to do today when we practice, or when we get into class and we practice, is you are going to have to know how to find the GCF, and then you're going to have to know how to pull it out or factor it out so that you can create this expression right here, including the parentheses. This right here is called the factored form, and we use distributive property to get it back into standard form. So we have factored form, then you distribute the 5 to the 4x, you distribute the 5 to the 1, and you end up with 20 times x plus 5. And so that's the distributive. So let's go back to our goal one more time. Today we will learn how to write and model expressions using the distributive property, which we did down here. How do you use the GCF and the distributive property to write equivalent expressions? Well, you just did. This expression, notice it doesn't have an equal sign, is exactly the same as this expression right here. So these two things are equal to each other because they're talking about the exact same values. Okay? So I'll have a couple of them for you to practice written on the board in the morning, and hopefully you understand factoring expressions. And that's all I have for today. See you later. Bye.